Good afternoon. It's really great to be here. Thanks for coming to this session. And today I'm just going to talk about Android and Docker. So how to utilize Docker for Android as a mobile world. My name is Jing, and I'm working for my taxi. First of all, I'd just like to show you a photo of my suitcase. I brought my suitcase to Italy, and it's my first time to be in Italy. It's a really great city here in Rome. I like it so much. So thanks for the organizer, Codemotion, inviting me here. It's so great. And why I want to mention that is because of I just unlocked an achievement, which is I finally can be proud of putting the sticker to my suitcase. I like Italy, finally. And now it's a mandatory boring part. I have to mention about my employer where I'm working. I'm working at my taxi. We have the office here in Italy and also in Hamburg, Barcelona, and we are the #1 e-hailing company in Europe. We are hiring, and it's a cool company. Just like you see, I'm using cool gadgets to control my presentation. Please feel free to ask me later on if you want to apply for the jobs here. Now I can just take it off. All right, now let's get back to the topic. First, let's start with the developer story. Here is a brilliant developer, just like all of you sitting down here. One day he got a fancy brand new laptop from his girlfriend. Of course, he will be super happy. And he decided to pull his Android project from GitHub and run it on the new brand fancy laptop. Not so easy. All of a sudden, he failed. Of course, missing different environments. I mean, it's not only happening to the new laptop or new PC, new hardware. I believe that most of you must suffer from the same problem, the misconfigured environment, even with the existing machine. It's not something fresh. It's even more pain in the beep. If you think further, if you think about provision tons of different machines, just like a mobile CI farm, it's just easy to get the brain overflow. You don't want that. It's tough. And of course, there are tons of different solutions to solve the problem. But today I'm not going to cover and go through all of them. I'm just going to talk about two typical ones. First, like the containerization and virtualization, the two most typical ones. So I would like to ask how many of you are Android developer? Please raise your hand. Cool, not too much. Thank you. And how many of you use Docker? Oh, same amount of the Android developer. Thank you. So I guess it's a good chance, just like we discussed about the Android, the Docker, and how to use Docker for Android. But here, I don't want to go through the tech details about the difference between containerization and virtualization. But I have to emphasize what is the major difference. It's a hypervisor, and we call it hypervisor overhead. It really brings you some pros and cons. The pros is, as you can see here, on the containerization side, it doesn't really have the guest OS layer because it shares resources. And here on the right side, on the virtualization side, because of the hypervisor, it brings a really well-isolated environment to each of the virtualization. But on the other hand, it's heavy-weighted. Okay, so which one are we going to choose? And why do you want to choose Docker? Of course, this talk is talking about Android and Docker. We're not going to choose virtualization. But why? Again, we just want to talk about two most popular ones from the containerization world and also the virtualization world. Who are they? Docker and Vagrant stand for containerization and virtualization. Just assume that there are two players trying to play the poker game. The first round, as we already mentioned, resource isolation. No doubt, Vagrant for the win this round. It provides extreme isolation, compete with the Docker side. And the second one is the supported OS. Of course, the name is called Virtualization. So Vagrant should support most of the OS in the world. And Docker, due to the implementation, it can only support Linux. All right, so Docker already lost 2 rounds. Come on, we're going to talk about you. If we lose all of them, then end of the session. Okay, finally, let's talk about the boot time and the stop time. Oh, Docker wins this round. Counter-Strike started. Docker can be started within seconds, while Vagrant has been already started and also stopped within minutes. It's due to the tech implementation because of the hypervisor overhead. It just makes it so heavy-weighted, and it has to be booted and stopped in minutes. And the last one is the size. Again, it's because of the hypervisor overhead. So in the end, I would say it's a deuce after 4 rounds. No really a winner, but we decided to go for Docker. Why? As the talk is going to talk about Android, we're not really running an Android environment in the production environment, so we only want to run Android for CI purpose or for some other purpose. So it doesn't really matter. Docker with low resource isolation, it doesn't really matter. It's not a big deal. We don't care about that. And what we care the most for the CI is we want to spawn an environment on the fly within a lightning speed. So we care about the speed. We care about the deploy size. That's why we choose Docker. And you would think about, okay, so let's just go for Docker and spin it up and play with it. It's not that easy. Why? Now I'm going to talk about the problem. Does anyone of you know what this logo stands for? And I will have a gift for you, a taxi coupon from my company. Anyone? Okay. So the coupon will be saved for the question later. This is called Infer. It's yet another static code analysis from Facebook. And I mean, there are already existing static code analyzer. And why do we want to use that? There are tons of different ones like SonarQube, this and that. But why do we want to use Infer from Facebook? Because this one provides some additional static code analyzer pattern, just like for the mobile side. For Android, iOS, it has a lifetime memory leaks due to the different lifetime calls, and this one has a pattern just designed for that. That's why we would like to use that. And for the ease of use, actually Facebook has provided a container with the Infer2 built-in inside. So I just download that and try to boot it up. Unfortunately, it doesn't really work out of the box. Why? Because keep in mind, every Android project has a different dependency. They are depending on different API levels, like Android API level 24, 25, 27. And apart from that, some of the Android project depends on different sub-dependencies or different dependencies, just like Google Maps, Play services, so that you have to download the corresponding service. And of course, I need to update the Android SDK inside the container provided by Facebook. And I failed. Why? Why it didn't work? Another chance, does anyone know why it wouldn't work inside the Docker container to update the Android dependency? I have another taxi coupon for you. Anyone? All right. So it's not about Android. Actually, it's a bit. It's about Docker. And AUFS is a default file driver from Docker. And it doesn't support the hard link move operation, which happens when you do the Android SDK update. So it fails due to that. Before we talk about the solution, how we're going to tackle this problem, I just want to talk about all of the best practice with Docker, the Docker file. The first one is single responsibility, just like coding. Each Docker container should only does one job. If you want to do different purpose, like if you want to play with a database, then please use a database container. If you need a web server, then web server container. If you want to bond them together, just use orchestration, use Docker Compose or anything else. And the second one is minimize the number of layers, because in Dockerille, each of the layer is actually an intermediate image. And if you keep the same thing and similar stuff within one layer, later will be save your time for cache the layer. So it will save your build time. And the other question is size matters. You should only really keep your size small, otherwise the build time will be really like hell. And also you should be aware whenever you install or uninstall some tool in different line, it will add up the image size. It's just like a Git system. It tracks all of the changes. But if you do the install and uninstall in the same line, the file system, the image size of the file won't be increased. And Docker file, you should also care about the readability. It's just like your code. If you make it readable, it will bring you the benefits later for maintaining it. You suffer from that, and you benefit from that as well. Okay, finally, let's go to the approaches to solve the problem of updating the Android SDK. The first one we can try is, because the problem was brought by the AUFS file system, then we just use a different BTRFS, the storage driver. Okay, it solved the problem indeed. And the downside is to use this one, it needs some effort. Secondly, it doesn't really bring any additional benefits. The others does. And just like most of the popular online third-party CI solutions, they also use one image per Android API level. Great, but what is downside? The downside is just like Android World. It has really lots of fragmentations. You have to maintain each of them by hand. It's bad. Finally, the solution we came up with is to mount the SDK volume as an external thing. All right. Then we're just going to talk about the details, how and why we want to use the mount solution. The first one is it's really minimum. Compared with the other two, we just download the standard, the bare bone Android SDK from Google, from Android website, so the minimum package, and build it into the Docker image file. So it's really minimum. All right, but just now I mentioned that each of the Android project is different. How can you update your Android? Yes, of course. Now we are talking about the flexibility. It's really flexible because we mount it as the external volume, so you can update the dependencies from the external volume. The file system is different. And why that is better? Because then you can tailor your own solutions, your own dependencies on your own, you don't have to worry about the different Docker image. We just use the same Docker image and tailor the different SDK volume. That's it. And as we mentioned, we mount the SDK volume, so it's also persistent. You don't have to download. If we build it inside the image, then you have to always update it again and again. But if you persist it, you can just reuse it later on for different containers. And last thing is, because it's persisted on a host machine or on a NFS, you can share it with different containers. Okay, speaking of share, speaking of NFS, the first thing is it will be hosted in one place, which is great. You will probably wonder, what is the performance? Because it will be shared across different container instances. All right, we're just going to talk about it within a few minutes. And the last thing, please bear in mind that we should only mount the volume, the SDK volume, in read only. Because imagine if you have different jobs, different containers running in parallel, and all of them trying to update the SDK all at once, then it will just mess up the SDK volume. So we should only make a dedicated job and mount it as a write and read. So do the update in that job. Otherwise, so in that case, you can make sure that the other jobs are in the safe side because it's read only. Now you wonder the performance. Let's just do a benchmark. The benchmark here, the first one is a bare metal machine, and it's really optimal. It's with a sample project, it's only 40 seconds. And the middle one is trying to run in the Docker instance, the container, and together with the SDK hosted on the same host machine where the Docker is running, where the container is running. And you can see it's just like add up less than 1 second, not a big deal. And the last one is using Docker and host the SDK volume on the NFS drive. It's slightly at 2 more seconds. Still, it's not a big deal because it's from the network, file system, could be a bit slower due to the network. Okay, but we haven't talked about the parallel jobs. So imagine we have multiple Docker instances and containers and trying to access the same NFS on somewhere on the cloud. So here it is that. I have 2 results, and one is slightly even better than the bare metal machine, and the other one is a bit slower, but again, it's not a big deal. And in total, the time is great, not bad. Let's talk more about the performance. Here I have another sample project, which has 2 build types, debug and release. And in total, and it has like 107 unit tests. And in total, multiply the 2 build types, will be over 240 test case unit tests. And together, it has 2 UI tests. And then we just tried with a Gradie job to run all of the tests and the compiling and checking. So with 2 different solutions, one is the on-premises Docker solutions, which I have mentioned about. And because it has a cached Android SDK, it's really fast, it's 6 minutes. And the other one is some online CI solutions. It's a bit over 10 minutes. So you can see it's already double the time almost. So why is that so slow compared with the server-side magic? Like, I mean, the backend compiling, backend testing, why is so slow? Okay, there are a couple of different aspects, but just let's hunt one by one. The first one causes slowness is the UI test, because the UI test has to be run on the emulator or simulator, or maybe physical devices. What kind of choices we have here? Of course, ARM emulator. Yeah, it will be slow. And x86 simulator. But if we want to do that, with ARM1, we can just directly use that and spin one up with inside the Docker container. It's very easy. But if we want to use the x86 emulator inside the container, you can do that. But you need to have the host to be supported by the KVM, which means you probably need a Linux machine. Otherwise, it's not possible. So why it's important? Because nowadays, we're not only talking about Android. Nowadays, lots of the companies who build a mobile application, they don't build only for Android. They build a complete solution across Android, across iOS. So, which means the CI also needs to be run to be suitable for the iOS. And you know, iOS is only compatible on the macOS. So that's why I want to mention that. If you have also the same solution for your iOS project, then probably you have a Mac Mini, which means you are lacking of the KVM support. So this will be definitely out for your solution. You have to think about something else. One is USB, but it's not really great. First, it needs a privilege mode, but you would argue it's not a big deal because we are not really running in the production environment. With a privilege mode, yes, of course, it's okay. But it doesn't work with macOS. As far as until now, Docker doesn't support the USB forwarding on the macOS. And of course, ADB supports Wi-Fi. You can just connect to your physical device via Wi-Fi. No problem, it sounds great. But unfortunately, that ADB is not perfect. You will have lots of headache trying to configure ADB with Wi-Fi. Not great. But still, you can think about some other solutions, just like the cloud solutions, like Codemotion. It's great. I would say that over 80% of the developers and testers, they use Codemotion for the purpose. We have talked about the emulator. I'm going to show you something. I need a deep breath. It's really tough. So these are all not all, just like some typical ones I found on Stack Overflow with different root cause. You can, if you search for emulator and with the tag Android, you'll find tons of them. And everyone is talking about different root cause and different problems and different solutions. It's pretty tough. Come on, I just want to have an emulator up and running. What did I do wrong? Fortunately, with our solution, we have made the ARM emulator, or if you have a KVM support, you can also run the x86 emulator inside the Docker solution. And apart from that, because sometimes you just want to see how it is going with your emulator, and then, of course, you want to have a visual feedback or visual interaction. And luckily here, we provide also a VNC support. But we do it in a different way. We provide two different images. One is a basic image without the VNC support, and the other one is with VNC support. Why do we want to do that? It's because of these, as I said, size matters. With the base image, the size will be only 563 megabytes. And the one with the VNC server will be like 60 megabytes increase the image size. So we have made two different Docker images for that. All right, now let's talk about the different performance about the emulators, the ARM ones and also the x86 ones. The ARM ones is the slowest one. With only 2 UI tests, it's already over 2 minutes. And the x86 one, it's only like 20 seconds. Nothing. And Codemotion is same like the exit itself is under the hood. It's x86 solution, so it's as fast as the one in the middle. And here is only for 2 UI tests. As I can tell you, for our company's project, it's over hundreds of UI tests. And if you use ARM one, it will be over 2 hours. And it's flaky, it's unstable, it can die at any time. Apart from that, there are other there are other performance issues, just like out of memory, because it's Java. It's different messages. When I encountered it at the first time, I tried to find, Google on the internet. I found some good articles written by some expert talking about the solutions and the theories and why is that. It's great. I found it so useful, but my suggestion to you is it's too long. I don't want to read it. And also to these cases, whenever you see different problems, you don't know what exactly you should do. And my advice, after tons of different tries, investigations, I figure out there are some different solutions you can carry out. And I'm going to share with you 2 different tricks. So if you break it down, it's just 2 different root causes. So why is the problem? Beforehand, because Docker containerization was invented after the JVM. So JVM is not really container aware. Okay, but since Java, if I remember it correctly, since Java 8 version 131, it is JVM aware. And what you need to do is just add these 2 params, which is, I don't want to read it out, but you know it. Just add these 2 Java options. And I did that, so my Docker container, it has the latest Java and it's container aware, and it's by default with these 2 Java options. So it's okay. And the 2 tricks I want to tell you is, you don't have to care about the error message itself. Just try to care about the exit code. Whenever you see it's 137, which means that you don't really have the right JVM or you are missing the Java options. So you should configure it. And it's actually killed by the kernel OM killer. And whenever you see 1, which means your JVM is container aware, and you have the right params, what you need to do is you probably need to just adjust the right memory, maybe assign more memory to your container, or try to tweak with your Gradie daemon and try to do some other adjustment with your project, because your project seems like really takes a lot of memory. So that's it. You wonder, how can I interact with the container? How can I run all of the Gradie tasks within inside the container? So the thing is, you can just talk with SSH. And we have enabled the SSH server inside the container. And I have to mention that there are some minor differences, that the system environment with Android SDK, environment variables, with Gradie variables, with Java variables, it's all set in the container, in the Docker image file. But we still have to copy all of the environment variables to the SSH. Otherwise, whenever you do the SSH to the container, you will not be able to call and get all of the environment variables. So, but it's all done within inside the Docker image. You don't have to worry. I just want to mention that. And the other thing is authorization, because you need to SSH to the machine. And the easiest way is you can just mount your authorization key to the container, to this folder. Then you can just be password free and SSH to the container. That's it. And why I want to mention the environment variables, it also matters. Just like the typical software engineering company, they use the most popular open source CI tool, Jenkins. And within Jenkins, the environment variables can be configured in different ways. In the global level, and also in the node level, because you have different nodes, machines. And last, you can also configure per job. So whenever, I can remember back many years ago, when we use Jenkins, it's just like whenever there's an environment variables, say, misconfigured, you have to go to all these different places and check it out. It's just time consuming. Apart from all of those I mentioned, can we get any better to improve the speed of the Android CI and the Android container? Yes, we can. What can we do better? Nowadays, lots of people are using Gradie. No aunt, no something else. So with Gradie distribution, and you can see here, it's about around 90 megabytes. Depends on your company's network or if you host your solutions on AWS. It always takes a bit time to download the Gradie distribution. So what can we do? I also provide the Gradie distribution mirror server, where you can just host the Gradie distributions on the mirror server and ask your Android container to talk with it. So you're directly downloading the Gradie distribution from the mirror server. And it's just, what you have to do is just change the configurations and asking it to download from there. And the other thing I want to mention is I also did the configuration here, try to work around the SSL certificate, so it only pops up saying that, oh, you're not downloading from the official Gradie, HTTPS, gradie.com, something like that. And what you need to do is just change your gradie.com to the IP address of your Gradie mirror server. And that's it. Can we do any better? Gradie caches. Because it's not only about Gradie distribution, it's also about your dependencies. Like I would imagine that most of the Android projects are using different third-party libraries. And you can just try to cache the dependencies, which can be up to 100 megabytes or even more. And you just cache it and mount it. Yeah, again, this is a typical image. Save your time. Don't waste your time in compiling or downloading. You can save your time for coffee. Okay, let's jump to the last part. Review the machine-dependent problems. This is another benefit we got from using the Android container instead of a local Android environment. Back then, our Android project is not really used across different countries, so we never realized that we have some hard-coded problems which is not saved in a UTF-8 encoding. And when running inside the container, it exposed saying that, oh, your unit test fails because we expected this, but it actually was that. All right. And also, again, as I said, we are all working in the same time zone and working in the same team, and we never realized we also have some JSON file, which is some mocked JSON response, which has some hard-coded time zone. And it has been reviewed by Docker saying that, oh, I have a different time zone, and your unit test expected a different one, and I failed. Great. And some other ones, just like the files and paths, because it's dependent on the OS. So before we talk about all of the Android parts, and now we are not only working in the Android world, what else we can use for the mobile? Integration test. Integration test, we are talking with the real server or some pre-live or staging server. And the mobile guys, sometimes they don't really know how to deploy the server in their environment because it's so complicated. They don't know how to configure it. They don't know how to put it up. But with the Docker, if you just wrap everything into Docker, then the mobile developer can be also able to just fire it up and ask their mobile application to talk with that. It's brilliant. It's really easy. And something else is nowadays, the Android and iOS is not only client only. It uses some other fancy language, just like Kotlin, and also Swift. It also enables the features like serverless. And for the mobile developer, now they can also write some code and run it in the container to do some fancy features in the server side, or maybe build up some web pages with written in Swift and run it inside the container. So that's all for my talk today. And last but not least, I want to mention that we're hiring at my taxi in different places in Hamburg, in Berlin, and in Barcelona. And of course, we have the office here in Rome, but it's mainly about marketing. And we also sponsor the visa, and we offer relocation. And we're hiring for lots of different job positions like mobile, QA, SDET, backend, frontend, all you can think of. And that's it. I would say thank you for your time today, and really thanks for Codemotion for offering the opportunity to talk with you.